Now, by now, like we have learned the difference between the learning and memory. So broadly we can say the difference between learning and memory is learning is to acquire certain new information, and because of the acquisition of that information you change your behavior or change any response to a particular stimulus, and that learning, if it stays for certain period in the brain, then that is called as memory. Okay, broadly we can say this, like not the exact medical definition, but broadly to understand the thing, learning is to learn about something, to acquire certain new information, and if we retain that information for a certain period in our brain, then that is called as memory. So based on this we can say the memory, it has 2 or 3 types, either the short term memory, the second is long term memory, and few of the books they say the long term memory is intermediate long term memory, and third is the long term memory. The basic difference between these 3 types is short term memory is it stays for certain time period, we can say for certain seconds or at the max for certain minutes, like 2 to 5 minutes or 1 to 2 minutes. So that is the short term memory, and intermediate is which stays from days to few weeks, then it will fade away. That is the intermediate long term. And the long term memory is it can be recalled up to either throughout the lifetime or up to certain years, like few of the memories of your childhood you still remember, right? And like say there are the certain incidents that happened in your life and you remember those incidents now, like now the age of 90-20, you may retain those certain incidents that happened in your childhood up at the age of the 40 or the 50, but not all the 100% of the events that happened. It will keep on reducing 100 to 90 or 80%. Okay, so we can say up to the years, certain years, or some of them you will remember throughout your life. That is the long term memory. Okay, now if we say what is memory, it's very easy to say the retention and storage of that new acquired information is the memory. Then how it is stored, where exactly it is stored? So we can say like there is a term that's called as memory trace or memory traces. What is this? Actually the memory is, it's nothing, it's not a certain thing कि यहाँ पे ये चीज़ है and you say okay this is the memory. No, it is not of the circular shape, it is of the rectangle, and some say no it's triangular. No, that's not the thing. The memory is, it is like we can say the change in the basic sensitivity of a synaptic transmission. Okay, synaptic transmission, like say there is one neuron, one second, like say this is the one neuron and it forms synapse with the second neuron. Okay, the second neuron. So there is a synapse over here. This synaptic transmission, it will get altered. Either it will increase, say there is one neuron over here, it has got certain so many neurons. Initially when you have not acquired any information, now there are these number 1, 2, 3 and 4 neurons, they are lying over here. But this major, the initial neuron, this neuron, it has got only the synaptic transmission with this one neuron. Maybe there, like there are so many neurons, second, third and fourth and fifth likewise, they are present, but there is no synaptic transmission. When you acquire certain knowledge, then there might be connection with this one. Formation of connection means there is a synapse present, but there was no synaptic transmission happening. Now their synaptic transmission might happen. That is one of the thing. The second is when initially before acquiring that certain information, now there was synaptic transmission happening between this and number 1 neuron. It might get increased after acquiring that information has resulted into increase the transmission or decrease the transmission with this one, or formation of the new transmission with the certain neurons. So these things, this synaptic transmission, the change in the synaptic transmission, either decrease or increase or formation of new. So we can say the synaptic transmission change in the, we can say, one second, this thing, synaptic transmission change, that is the neural basis of memory. And this, like say there was a connection over here with the one neuron, it increased or it formed new connection with this. These are known as memory trace. So these formation of the new memory trace, formation of the new like synapses, or strengthening or weakening of already present synaptic transmission, that is called as the memory trace. So new, or we can say the facilitated pathway, they are known as the memory traces, and these memory traces are nothing but whatever you have acquired the information you have stored in your brain. So that is called as the memory. So now if we look at this synaptic transmission increase or decrease, we can, one sec. So this change in the synaptic transmission, this is called as or known as synaptic plasticity. So the ability to learn and form the memories, it happens because of the ability of neurons to change the way in which they communicate with each other, right? Like these memory traces, the strengthening or facilitation of those synaptic transmission, the ability of the neuron to change the way in which they communicate with each other, that is the neural basis of memory or learning, we can say, and that is known as synaptic plasticity. So synaptic plasticity is the basic fundamental neural basis of the memory. We can say the key to the memory is this synaptic plasticity, and this is nothing but alteration or change in the strength of certain communication between synaptic communication between certain neurons, that is called as synaptic plasticity. So this synaptic plasticity, these changes like in the memory traces, these strengthening of the synaptic transmission happening, it can be either for a short term or for the long term, okay, short or the long term, and it depends, these short or the long term changes, whether it will happen the long term or the short term. It is as a result of the history of discharge at a synapse. Say I will take the example, like there is one neuron over here and this is the second neuron. You repeatedly stimulated this particular neuron, okay, repeatedly stimulated means you start to learn certain things like new topic. So this neuron will get repeatedly stimulated, and because of this repeated stimulation there will be the release of neurotransmitter, and that neurotransmitter will generate EPSP in the postsynaptic neuron, and the action potential will be generated, and that has got certain further neuronal connection, or we can say the synapses. Initially when you haven't read about a certain new topic, there was synaptic transmission happening, but not much or very large amount or at a very large speed this neurotransmitter release was happening, but you stimulated this neuron. Like say आप कहते हो ना कि जैसे electricity connections are there, like there is a feeder, आपके लोकेलिटी में एक मेन ट्रांसफार्मर होता है, वहाँ से कनेक्शन आ रहे हैं हर घर में, ओके, एंड अब ज़रूरी नहीं है कि जो कनेक्शन आ रहे हैं आपके इलेक्ट्रिसिटी के, तो वहाँ पे आपने अपनी लाइट और जो भी है कोई भी इलेक्ट्रिकल अप्लायंसेस वो स्विच ऑन कर रखा है या नहीं, राइट? जैसे इस पर्टिकुलर एक घर में इसमें ऑल द इलेक्ट्रिकल अप्लायंसेस आर स्विच्ड ऑन, but there is a connection with all these 1, 2, 3, 4 houses, but they have switched off their electrical appliances. At one particular time they switch on. So, we can say this similar thing, the synaptic transmission, the synapse is present over there, but these electrical appliances were not switched on. You started reading about the certain new topic, then that certain new topic stimulate this neuron, so automatically switch on the light. Did you get my point? Okay. So, this synaptic transmission will happen, and depending on how aware or how seriously, attentively you have read about that topic, there will be different types, like we can say the strengthening, either there will be increased or less increased or more increased release of the neurotransmitter and stimulation or the generation of EPSP in this postsynaptic neuron, right. So, we can say based on the history of the discharge, like you have read that topic, synaptic transmission happened, now you closed that book. After some time or after 1 hour, 2 hours, if you try to recollect, then who is responsible for recollecting that information you have gathered few hours earlier? This synaptic transmission, because of the history of the discharge that happened 2 hours ago, the synaptic connection, the synaptic conduction between these two neurons will strengthen. That is the main basis of this, we can say, the synaptic plasticity of the memory, and this strengthening of the communication between these two neurons, it may be either due to the change in the presynaptic neuron or due to the change in the postsynaptic neuron. Like in certain conditions, there are so many mechanisms. Broadly, we can say there are the 4 mechanisms, either the post-tetanic potentiation, then there will be the long-term potentiation, and then there can be the long-term depression. Okay. So, that we will talk. So, depending on either bringing about the changes in the presynaptic neuron or the postsynaptic neuron. Out of those, one is the post-tetanic potentiation. Now, what is the post-tetanic potentiation? It is production of enhanced post-synaptic potential in response to the stimulation. It occurs after a brief tetanizing train of the stimuli, that like you started reading about a certain new topic that will generate the tetanizing train of the stimulus in the presynaptic neuron, and this post-tetanic potentiation, the result of this repeated stimulus, it will last up to the 60 seconds. And what happens when you keep on stimulating, like if you recall back the happening, like any synaptic transmission that happens between the presynaptic neuron and the postsynaptic neuron, over here it is due to, like say, if you stimulate, there is generation of that impulse, it will come, and what happens over here, there will be opening of the calcium channel, there will be the calcium influx, right. So, that calcium influx will happen, will go into the presynaptic membrane, and the vesicles which contain the neurotransmitter, they will attach to the membrane and exocytosis happens, and that needs calcium. So, the calcium accumulate in the presynaptic neuron because of the repeated stimuli, and intracellular binding sites that keeps the cytoplasmic calcium low are overwhelmed. What does it mean? It means, like say, if I try to draw the diagram of this presynaptic neuron, and this is initial part. Initially, the calcium is present inside, but this calcium is bound to certain binding sites. So, it is not available over here for the vesicle to get attached and release the neurotransmitter. But because of the repeated stimuli, calcium channel opens, extracellular calcium enters in the cell, and whatever the binding site were there, they will totally get saturated. Now, the free calcium will be present, and this free calcium will attach the vesicle to the synaptic membrane and release the neurotransmitter. So, that is the meaning of intracellular binding site that keeps cytoplasmic calcium low. They are overwhelmed, and there will be more and more availability of the free calcium to release the neurotransmitter. That is called as post-tetanic potentiation. Okay. Now the habituation, like in the previous section we have read about habituation and sensitization, that's part of the learning. So this habituation and sensitization, it's part of the learning and it's also a part of the memory. Okay, so it's kind of a common topic for both learning and this one memory. So habituation is learning not to respond to repetitions of an insignificant stimulus. Like these two words, these key words, they are important. Repetition of insignificant stimulus. Like when we provide that insignificant stimulus first time, body will respond to what is it response or orienting reflex. Okay, and on the second, third or continuous repetitively application of this same stimulus, it will evoke less and less response as it is repeated, and eventually our body or our system, nervous system, will get habituated and start ignoring it. The perfect example is like the loud sound. If you hear any sort of the loud sound in your surrounding, first time you will startle. That the startle response is what is it response. So that startle response, it is occurring to the novel, a new thing for that first time loud sound. Now that is insignificant stimulus in the surrounding. Say when you are studying or listening to this video, and in the surrounding there is some function going on, and that celebratory fire, if it occurs first time, then that to that novel stimulus you will respond by startling कि ये क्या हुआ all of a sudden, or you will get oriented toward that new stimulus. But if it continues, keep on occurring again and again, then eventually the body will get habituated. That is the habituation reflex, right? So the example of this is the loud sound. And what is the mechanism, physiological mechanism of action? Like normally what happens in a synapse, like say this is the presynaptic neuron, and then this is the second, this one is the post-synaptic, and this one is the pre-synaptic neuron. So if you provide a stimulus over here, what will happen? There will be generation of the action potential, and this action potential will end up at this terminal by opening of the calcium channels, and these calcium channel will move the calcium ion into this now terminal, and so that this calcium will get accumulated in the cytoplasm, and it helps in exocytosis. Like say the neurotransmitter, they are stored in these vesicles. Okay, these vesicles will release the neurotransmitter via the exocytosis, and for the exocytosis there is requirement of the calcium, that you all know. So because of generation of the action potential, calcium channels open up, calcium concentration increases in the cytoplasm, and that releases the neurotransmitter, right? That releases the neurotransmitter. So that will happen at the first stimulus. Amount of the neurotransmitter released in successive responses, it will gradually decrease. Why there is decrease? The decrease in the neurotransmitter release is happening because of decrease in intracellular calcium due to gradual inactivation of presynaptic calcium channel by repeated action potential. Say this in the presynaptic neuron, first action potential, there is opening of calcium channel, movement of calcium inside. Say the second action potential, similarly if you provide the third, the fourth, by different color I am depicting it, by fifth. So in the second, what will happen? Now there will be the opening of the calcium channel, but it will be lesser than the first one. Similarly in the third, again there will be very less opening of the calcium channels. With the fourth and fifth, there will be very minimal, or you can say very less amount of the calcium channel opening. So with increasing the number, like from 1st to 10th, the opening of the calcium channel is also decreasing, and because of that the neurotransmitter release is also getting decreased. So that is the mechanism of action of habituation, and that happens for the short term. Like say if you keep on providing the stimulus for certain time, maybe minutes or hours, In the case of the long term, like for the days or the weeks, this mechanism of action won't be helpful. It will happen, the long term habituation will happen because of the decrease in number of synaptic ending, decrease in the number of the synaptic ending as well as active zone in the remaining terminal. So what does it mean? It means, like say if there is presynaptic neuron, this one, it has got 3 or 4 synaptic, like say these endings, and they are happening over this postsynaptic neuron 1, 2, 3 and 4. Initially there might be active zones in all those 4 ending. On repeated habituation there might be decrease in either 1 or 2 of the postsynaptic ending, right? Only 2 will stay, and out of those 2 staying, the number of active zone will decrease. Means the neurotransmitter, say from this side, the neurotransmitter is getting released and acting at postsynaptic at the 3 sides. So instead of the 3, it will act only on 2 sides. So that is the long term effect. And one like example of the habituation in day to day activity, everybody we have this example, that is like when you take a bath and wear the clothes. Initially when you are wearing the cloth, your body will feel the sense, you will get aware, like the touch sensation of the cloth on the skin, right? Touch sensation of the cloth on the skin, but immediately your body will get accustomed and you won't be aware about the clothing, right? अगर आप अभी ध्यान से देखोगे नहीं, if you bring your awareness toward your clothing and touch sensation, you will feel there is a touch sensation, but it was present before too. Okay, throughout the day it was present, but your body stopped like responding to this touch sensation. Okay, this awareness, that is the habituation. Means our body is getting already got habituated to that repeated touch stimulus. Okay, and opposite of it, habituation is sensitization. Okay, opposite of it. Now just imagine you are wearing the cloth, and if there is any boil or fruncle or any cut in your skin, right, means there is some sort of the inflammation in the skin. Then at that particular area where there is some sort of the injury, the touch sensation of the cloth, you will become aware throughout the day until and unless that inflammation gets, you get recovered from that inflammation or from that boil. That touching of the cloth on the skin will make it unpleasant. That is the sensitization. And what is the mechanism of sensitization? The physiological mechanism of action of the sensitization is presynaptic facilitation. Presynaptic facilitation. What does it mean? Let's see over here. The increased responsiveness to innocuous stimuli that follow the presentation of a strong or noxious stimuli. What is the innocuous stimuli over here? The touch of clothing, and followed by the presentation of a strong or noxious stimulus. What is the noxious stimulus? That painful, that inflammation, right? So the noxious stimulus, it causes discharge of the serotonergic neuron that end on the presynaptic ending of that sensory neuron of the innocuous stimulus. That is called as presynaptic facilitation. Presynaptic facilitation of the synaptic transmission brought about by a third neuron. It is, that third neuron is called as facilitatory neuron. It can be transient for certain very less time duration, or it can exhibit feature of the short term or long term memory. Let's take the example of this, like what is the meaning of this pre-synaptic facilitation. Say this is, I am drawing the innocuous stimulus, that touch because of the clothing touch. Okay, and with this red color I will try to draw, this is the post-synaptic potential, post-synaptic neuron. This is pre-synaptic neuron. Okay, that's the normal. Now that innocuous stimulus this is the presynaptic neuron. Now this thing, let me draw it with green color. this is the noxious stimulus. So, this blue one, it depicts the clothing, okay, it depicts the clothing, and this one your what kind of the sensation your body is aware or not, right? And this green one, it depicts that inflamed part, okay, inflamed part of the skin. Now what does it do? Initially, if this part is absent, what was happening? Because of the touch sensation, clothing, there was release of the neurotransmitter. After a continuous stimulation by the clothing, there was reduced number of the calcium channel opening, so it was letting reduced neurotransmitter release. That was happening in the case of habituation, right? Habituation. Now what has happened? This neuron, the noxious stimulus due to the inflammation, this is called as facilitator neuron. What does it release? Because of the stimulation of this neuron, it is releasing a neurotransmitter, and that neurotransmitter is serotonin. Okay, serotonin neuron. Now this serotonin, it acts on the receptor present in the presynaptic neuron. There are the serotonergic receptors. Because of the release of the serotonin, it acts on these receptors. And what are these receptors? These receptors, it has got, because of the activation of this serotonergic receptor, there is increased in the cyclic AMP. Increase in the cyclic AMP. Cyclic, what is it? It is the second messenger system. Like if you recall back your endocrine part, in the receptor cell surface receptors or the intracellular receptor. So in the type of the cell surface receptor, when the hormones or any kind of the substance neurotransmitter gets attached to the receptor, it will initiate certain messenger system, like because of the attachment of the neurotransmitter at the ligand gated or the voltage gated channel, it will initiate a cycle, and because after the attachment there will be release of certain, like say substance, cyclic AMP or the calcium. So this is second messenger in the case of the serotonergic receptor, the cyclic AMP increased. What does this increased cyclic AMP do? It is increasing, if we look over here, this cyclic AMP. Why it is increased? Because of the attachment of the serotonin to the receptor. And who is increasing after the attachment of the serotonin to the receptor? Adenylyl cyclase enzyme activity happens. The adenylyl cyclase was present, it will get activated, increase the cyclic AMP. Increased cyclic AMP increases the protein kinases. Either it increases the protein kinases or it activates the protein kinases that were present inside this neuron, the presynaptic neuron, in inactive state. Now when they get activated, there will be two type of the changes, either the short term changes or the long term changes. In the short term changes, what is happening? Because of the increased protein kinases, potassium channel phosphorylation happens, and this phosphorylation of the potassium channel inactivates the potassium channel. And because of the inactivation, say if let's take this thing, see serotonin gets attached at the presynaptic neuron. What does it do? Activates adenylyl cyclase enzyme. What does it do? Increases cyclic AMP. What does cyclic AMP do? It activates protein kinase, certain protein kinase, increased activity of the protein kinase, and in turn protein kinase, it phosphorylates. See, in every second messenger system in the receptor, either the phosphorylation or the dephosphorylation happens of certain proteins, and that either the phosphorylation and dephosphorylation, those proteins will either get activated or inactivated. In this situation, the phosphorylation of a component of a potassium channel, say this is the potassium channel, a certain segment or subunit of the potassium channel will get phosphorylated, and this leads to closure of the potassium channel. And what does it mean, closure of the potassium channel? See, if we draw the diagram of this presynaptic neuron, if we try to draw the diagram of the action potential, this is the action potential, in the repolarization phase, right, there is opening of the potassium channel, and because of the opening there will be efflux of the potassium ion, efflux, and it will bring down this action potential. If this efflux stops because of the inactivation of the potassium channel, what will happen to the action potential? Instead of getting repolarized, it will stay in a depolarized state, and slowly it will repolarize. So we can say the duration of action potential has increased, right? Duration of the action potential has increased by this much. Now if the action potential stays longer than the normal, then what is happening? Because of the action potential at the end of this sensory neuron, there is opening of the calcium channel. So because the action potential is staying for longer duration, more number of the calcium channels they are opening, and more influx of the calcium. What does increased calcium do? More and more release of the neurotransmitter, more and more release of the neurotransmitter. So we can say this post-synaptic neuron, because of the increased amount of the release of the neurotransmitter, it will respond more and more neurotransmitter is getting released, more and more generation of the excitatory post-synaptic potential in the post-synaptic neuron. So more and more generation of the action potential. And who is doing this? This is done by this facilitated neuron by releasing the serotonin. Okay, so that is short term effect. And what is the long term effect? Long term effect is, instead of increasing this thing, say if we look at this flowchart, long term effect is phosphorylation of the transcriptional regulatory proteins, means certain protein synthesis that will get increased, and because of the increase in the protein synthesis, growth of the synaptic connection will also increase. So that's how the sensitization happens. So sensitization is happening because of presynaptic facilitation. Presynaptic facilitation. So presynaptic facilitation of the synaptic transmission brought about that third neuron, which is called as facilitatory neuron. It can be transient via the short term, or it can be longer duration via, which will be helpful in short term or the long term memory, via the synthesis of, say this, if we look at this thing, via the protein synthesis and growth of the presynaptic and postsynaptic neuron, their connection. That is the long term effect. Short term is due to calcium mediated change in adenylyl cyclase, right? Adenylyl cyclase.